Hello there guys, welcome back to another epic inexorable maths video. In this video we're looking at finding the area of a regular hexagon as I've drawn there, and we're saying that each side of the hexagon has a length of x units, meters, centimeters, whatever you want. What is the area of the hexagon? Now there are loads of ways to do this. This is not the only way, but I think maybe this is the easiest way, okay, if you want to express it in terms of its side lengths. Okay, which is not always the case, but let's do it. So the way that I would do this is I would split this thing into 6 equilateral triangles. It might not be immediately obvious that they are equilateral triangles, but I'm going to make a really good case for it in a second. Okay, so not a perfect drawing, but there we are. 6 triangles at least. Now every triangle is identical. Hopefully that's obvious because the base is the same and each of these lengths here is all the same. And also, because this entire thing is 360 degrees, one of them would be a sixth of that because there are 6 triangles. So this is a 60-degree angle, as is this, as is this, as is this, as is this, and as is this. They're all 60-degree angles. Because the lengths, if I call these maybe L, I'll say these lengths are L. Okay. Because the lengths are all the same as each other, all L, then it's definitely the case that each triangle is an isosceles triangle at the very least, which means that the 2 angles here for each triangle must be the same as each other, because that is true for isosceles triangles. Because this is a 60-degree angle, and the 3 angles must add to make 180 degrees, and these are the same angle, then this must be a 60-degree angle as well, and this must be a 60-degree angle as well. And because of that, we can see that the length L is equal to x, okay? So that's how we know they definitely are equilateral triangles, and that's how we know what L is. So now I'm going to rub off all of the L's, and we can continue. We're actually almost done, believe it or not. Okay, so all of these lengths are x as well. So that's how we know we're definitely dealing with equilateral triangles. Let's work out the area then of one triangle so that we can then just multiply it by 6 at the end. So the area of any triangle is 1/2 AB sine C, okay? And that's in the situation where you have, let's say this is A, this is B, this is the angle C, okay? That's any triangle. Doesn't have to be an isosceles or an equilateral or anything like that. Any triangle, 1/2 AB sine C. If this is A, this is B, and this is C. So we can use that for our one. So the area of one triangle here, this one here, is just going to be 1/2, let's say x times x sine 60. Okay, so 1/2 x squared sine 60. Okay. And if you know your trig ratios, then you know that sine of 60 degrees is √3 over 2. Okay. And this simplifies to give us √3 over 4 times x squared. That's the area of one triangle. The final step, and then we're done, is to just times this number by 6 because there are 6 triangles. So that means that our answer, the area of a hexagon, is this times 6, √3 over 4 times 6 x squared, √3 over 4 times 6 times x squared. And then I'm just going to simplify this a little bit. So 6 over 4 is the same as 3 over 2. So the final answer is √3 over 2 times, I've missed out a 3 there. 3 √3, I should say. 3 √3 over 2 times x squared. There we go. And that is the value of the area of any regular hexagon if it has a side length of x. That's how it's done. Thank you guys so much for watching. As always, I highly appreciate it, and I'll see you in the next video. Cheers.